Well, hello everyone. Welcome back to Adrian's Digital Basement 2 Super Mini Mail Call. Let's jump right into it. This package comes from Michelle. Michelle has sent stuff in to the channel a bunch of times before. In fact, last time I had a package from Michelle on Super Mini Mail Call, I said his name was Massimo, which was wrong. So sorry about that. We have a note, which we'll take out a look at in a second. Looks like we have a blanket in here, but I think it's a blanket that's wrapped around some retro stuff. Okay, I remember now what we have here. We have a very, very damaged floppy drive. Some time ago, I bought this 1551 I found in the UK for a very reasonable price. Unfortunately, the poor packaging and criminal handling during shipping shattered the case of this rare drive. Internals look kind of fine. Recently, I posted a picture of it on Bluesky and you suggested to get a 1541 case and repaint it. The endeavor of looking for a 1541 painted and trying to replace the label. I'm bummed and I lost interest in it. I received a partial refund for it and the seller doesn't want it back, so I'm donating it to the basement. Hope you'll find a use for its guts. I haven't seen a 1551 on the channel yet, and maybe it'd be interesting to have it to play with. And yes, I don't have one of these disk drives, and boy, my camera is making this look all weird and banded. It's the LED lights, I think. Also, there's a 1531 data set in the package. I think you already have one of these, a mint one, but this was just $6 from the same vendor. And these things might have been together for 40 years anyways, and didn't want to separate them. Thanks for your great content. You always share. No Italian candies this time. Sorry, I haven't been back to Italy yet. I didn't know this was coming to me because I saw the photo on Bluesky and I thought, oh yeah, that would be possible to, swap the case from a 1541. I assume it's similar, maybe? Okay, well anyways, let's take a look at this thing. So what are we looking at? Well, this is a floppy drive for the Commodore 16 and +4 line of computers. It uses a parallel type interface, so it plugs into the cartridge connector for faster speeds. Now, one of the issues right off the bat is that this disk drive does need external power, and it was designed, or is a UK market disk drive, therefore 240 volts. And to use it here in North America, I'd have to swap out the power supply, which actually is not that hard because I happen to have parts 1541 drives. Now the thing is, I had recently just took my parts 1541 drives over to my storage unit. So unfortunately, that means I don't have those parts handy in the basement because I didn't realize that I would be needing to work on a disk drive like this anytime soon. So what has happened here? Well, oh boy. Yeah. How freaking horrible. I don't think that many of these disk drives exist on the planet. Not that many were sold. And this thing no longer is attached to itself. These standoffs snapped off. That one is just missing the screw, I guess. This one is broken as well. The front has issues. And this sucks because this badge, I think, is the same as the 1541, I think. But clearly, it's quite mangled. So, let's get this out of the bottom. There are normally 6 screws that hold it in. That one is just completely gone. Oh, man. I mean, is it going to possibly work, this thing? After the damage it's been through? Maybe. Now, as I said, my suggestion was just to take a 1541 case, paint it, or even not paint it, just leave it, transfer the badge over, and if the rest of this works, which probably does, I don't know, then it would just be a brown 1551. Let's lift this out. Oh boy. So I really am now a miracle worker at trying to repair plastic pieces. I assume the plastic pieces, the broken ones that is, are here. But this would be a project for someone who is better at welding plastic together. This is ABS, so you could use acetone, but it would be a massive jigsaw puzzle, and it would be pretty ugly as well because, yeah, I know when you plastic weld with ABS, it's not terrible looking, but I mean, there are huge chunks missing here that will have to be all reassembled, and it would be quite the endeavor to do. Look at this. Look at this. This is just split completely. That's all smashed out. I mean, that's not a big deal, right? But like, there's holes here where the standoffs completely just snapped off entirely. I mean, they must have just packaged this with like a piece of paper and put it in a box and then shipped it internationally. I don't see how else this could have gotten so destroyed. What a travesty. What a freaking travesty. In the disk drive, there's pieces inside of it too. So all this stuff just floating around. Okay, so flipping this over, besides the plastic pieces that are stuck in there. Anyways, there's the transformer that's not going to work until it gets swapped over. What this does is it takes your mains AC, so 240 volts in case of this drive, or 120 for US ones or US Canada, and then it outputs like some AC voltage, 9 volts for the 5-volt rail, and then probably like 18 volts, something like that, that gets regulated down to 12 volts. So these are the linear regulators. It's just super simple, and the connection here is the same as a 1541. Like I said to Michelle, all that's really special about this is the floppy drive, which, to be honest, this is just a Neutronics drive, so that's probably even the same as a 1541, but it's this controller board, and this with the cable. This metal chassis that the drive is in, that's all bent right here, that's the same between 1541 and this drive. And I think this should just mount straight up to the 1541 chassis. And like I said, I have the entire spare parts. And so yeah, just taking a 1541 as a donor drive should make this work. I think what we need to do here is just give this thing a test first, see if it can work, and then I'll have to do a follow-up video at some point in the future where I go and I grab the spare drive and then transfer this into that. Now, one thing I'm noticing is this is not quite right. So that's still working, but why is this so loose? I think the front, looks like the whole front panel is broken. Is it? Or the screw's just loose? Oh, the screws are just loose. Oh, that's lucky. It's just a Neutronics mechanism, or sorry, Mitsumi. And I think it's probably the same as the one from the 1541. So yeah, single-sided drive, it's not double-sided, it's just a little pressure pad. It doesn't look like it has a track zero sensor either. Definitely doesn't move very easily. Needs a little lubrication. Yeah, no track zero sensor. This is the speed controller for the spindle motor. That's the speed control right there. This doesn't look like it's got the sticker on the bottom right here to show you the RPM. And then the mechanism itself connects to the main board through these connectors. Looks exactly the same as a 1541. The biggest problem or difference is the case molding was different on the back. Let me grab the case. That's the power switch, that's the fuse holder, that's the IEC mains input. And normally on the 1541, the two inputs for the IEC, as in like the serial bus, are up here. But this has a little square thing that seems to align, yep, with this interface cable that comes out. And that hole's not there on the 1541. Obviously it's got two holes there, and there's nothing that kind of coincides with that. So we'd either have to try to use one of those existing holes that are there, or just probably Dremel away carefully, try to Dremel away or nibble away some of the plastic case on the 1541 so that that has a place to come out, and then the other two holes would just be there. And then ideally, one could just paint the 1541 case a dark chocolate brown, and it would look pretty much the same. Just transfer over this badge. Nothing's on the bottom. And yep, that should theoretically resurrect this floppy drive. Now, as for the power supply, as I mentioned, all you need to do is switch the transformer over from US 1541, US Canada 1541. You can also use switch mode power supplies. All you have to do is desolder these two linear regulators, and you would then bypass them, and then you could connect up the 5 volts and 12 volts to here. This is the input that right now goes to the transformer. And when I get this board out of here, you'll see the transformer's under there. You just remove that, recycle it. It's full of copper, so there's plenty of recycling material there. And then you just mount those two power supplies inside. And you would have a very, very light disk drive, it'd be much lighter. It would also be much cooler because you wouldn't be using these regulators here, which generate a bunch of heat. One more screw. That's one of the reasons why these floppy drives get so hot, is this linear regulation that's happening. It was, I don't know why they did that, and they didn't switch to a switch mode power supply, especially by the time they made this disk drive. So let's see how this works exactly. Why aren't you coming out? There we go. So, oh wow. Factory bodge wires. That's pretty funny. They are glued down at least. So inside of here, we got the plastic pieces, loads of them. But switching the transformer out, if I was going to keep this metal chassis, it'd be simply just remove this, unscrew it, and then we would have to desolder some wires and stuff like that. Or ideally, if you have a donor drive, you'd be taking the entire chassis anyways. Look at this. That's bent down. I think that was done by Commodore. I really do. Because this sat here, there were no screws in those. I don't know. That's kind of odd. All right, so let's take a closer look at this PCB since I don't really know much about it. A 6510, that's the CPU from the Commodore 64. Now it's a T variant, whatever that means. Maybe it's somehow limited. And then we have a 6525 instead of a 6526 like on the Commodore 64 and the 1571 disk drive. We have that. This is going to be the ROM chip. It's a single ROM. It's in a socket. That's kind of nice. We have static RAM, 128 kilobits of it. So if my math is correct, this would be 16K of RAM. The original 1541 only had 2K. So that's a big difference. This MOS chip is probably some type of a PLA. I'm assuming if that goes bad, probably renders this floppy drive, you know, useless. This is a hybrid module. I think the 1541-2s use this. It's got a bunch of like analog electronics just inside of there. I don't think they usually fail, which is good. But this is the computer part of the disk drive, right? But the part that talks to the read-write heads and stuff like that, I think that's all happening inside of this hybrid IC. In fact, yeah. So this is the read-write heads, and this probably goes right into this and does timing, decoding, stuff like that. Some kind of Hitachi IC. We're gonna have to look up the HD61215P. I don't know what that is. A little bit of Google Lens says that it's a chip for the 1551, which is this disk drive. It does something and it costs 20 bucks. Looks like it's also used on the 1571. Red and green LED always on and motor never. How to check the reset line. So this is obviously some kind of PLA type chip as well, or does a bunch of stuff, like integrates a bunch of logic. It really allows this board to just be a lot smaller than the original 1541, which just had more stuff going on. But really what we have going on here is a 6502 or 6510 in this case. We have 16 kilobytes of RAM. We have a CIA type IC. This probably is what communicates with the cartridge here on the end. And then we have ROM, of course, to run the CPU. You need ROM, RAM, the CPU itself, clock, reset, stuff like that. And then we have this PLA type stuff and this hybrid. And really, just like the 1541, this is an entire computer inside a floppy drive. And I made a video on repairing 1541 recently on the main channel. I mentioned the fact that it's a full computer, and people are like, no, it's really not. Let's be honest, it really is. With a replacement ROM, that is, you could totally change the functionality of that to be a full computer with a terminal, serial console, everything like that. I mean, the biggest problem is the limited RAM on there. 2K, you can hardly do much with that. But it doesn't have a graphics chip. But you don't need a graphics chip to have a computer because serial I/O, you need a way to get in and out of the computer, and it obviously has a serial bus. So anyways, same thing going on here. I don't see anything wrong with this other than things are all smashed. We need to get my step up transformer, that is, so we can get 240 volts to feed into this thing. Oh yeah. Oh, I didn't realize it's got a pass through. So that's interesting. Yeah, these are held together with clips, and I really don't feel like taking this apart. I'm sure if we look online, we'll find photos of the inside of this. Well, probably just uses some latches or transceivers to hook up at least the 8-bit data line and a few address lines, which is all you really need to do some communication over a couple memory mapped I/O addresses between this and the computer. And it will just load or buffer the disk access into the RAM, and then the host computer could just access that directly. There's nothing to say that we couldn't adapt this to work on a Commodore 64. There would just need to be custom routines. There's probably a ROM chip in here that maybe when you pop it in, it then supports this. I'm not 100% sure. All right, so I think what I'm gonna do is grab my step-up transformer and we'll run this just as is, see if this thing works. It should be just like the Commodore 1541, where you get a bit of activity out of the LED and stuff. And then the LED should turn off once the system initializes. So for the step up, I'm going to use this thing here. This is it was a step down. It was 240 volts to 120, which is why it has a US plug on it. But I took it apart and reversed the transformer. So now it's a step up. And I just had to switch out the power cord because it had a UK power cord on it. So now it's got a regular US power cord. Okay, so we'll just move this over there. And is the power switch on or off? It is currently off according to the back. So that's on, so we have 240 volts. Here we go, 3, 2, 1. Okay, so this spun and then shut off. So let's just lift this up so you can see the power LED. Oh, the light didn't even turn on. You know, that might be normal because I'm noticing when I turn off the power, it blinks ever so slightly. But when I turn it on, it doesn't. Did the head move? Yeah, moved a little bit. I'm assuming this thing is probably working fine. Just make sure that doesn't slide around. Now let's see about this. I don't think this is broken, by the way. I'll turn off the 240 volts. Looks like this got bent a little bit. Let's grab something to try to straighten this out a little bit. Needle nose. There we go. So I just popped that in, and you can see now, that was easy. Just bend it a little more. Okay, yeah, that fixed that. It's nice that it's all metal. A lot of times this piece, this one right here on the shaft, is sort of a nylon, and it shrinks and then cracks. But Mitsumi Neutronics, they used metal, so that is not a problem. This whole thing still seems to work without issue. Okay, for testing, we're going to be using the Commodore 16, kind of the worst Commodore bread bin pretty much ever. I really am not a huge fan of these computers. Let me just put a couple screws back into this. So I don't like that the board is just loose here, and I could bump it and then it could, short out or something. So we'll just put a few screws in there loosely, just to keep it in place. There we go. Yeah, anyways, I'm just not a huge fan of these computers. I feel like, they had good ideas and it wasn't going to be a successor, but it was supposed to be a very cheap computer, but it ended up not being that cheap. I mean, in the end it did. It just feels like this thing is such a letdown compared to the Commodore 64. It's so much less good in so many ways. The only thing better about these +4 and 16s, is that they have redefinable colors. So I think there's more than 16 colors. I forgot how many, 64 maybe, but no hardware sprites, no hardware scrolling. The sound is just not good. It's more like VIC-20 sound, very simplistic. There's just so many negatives about this thing. And then of course the fact it's not compatible, even though it looks good. The keyboard is this weird layout. What's the deal with this? I don't know. Yeah, so many things are just weird. The other thing they did is they changed it to a DC barrel jack, and it just says power, and I don't remember what this thing takes. So I'm gonna use my bench power supply. I have a power supply for this that just isn't handy. So what I need to do is we need to quickly test to see if this is center negative or center positive. So we are in continuity mode. Let's get this cartridge out of here. Should be a shield in here. Yep, I think it's center negative. Yeah. So the red wire is the center pin, right like that. And when I plug that in and I touch the shield inside the computer, why? Why did they do that? Now I have no idea if there's a diode in here that protects this thing if you do reverse current it. But anyways, so just know that if you have one of these machines, don't just hook up. I think, you can use a 9-volt power supply and it's going to work, but you do need to swap it around. All right, I'm at 7 volts. Let's turn this on. There we go. It's working. Okay, it flashed because I think this has a PAL NTSC switcher in here. That was a video I did a while back. For video, by the way, we could just use a 64 or VIC-20 cable like this. All right, we are going to use the retro tank here. All right, let's switch this to composite. It is. We are going to use this. Let's turn this on. See if we get video. This might be in PAL mode, NTSC, I don't know. Okay, 60,000 bytes free. So that is one benefit actually if you're a basic programmer. The basic on here is basic 3.5. Basic 2 is what's on the 64. This is a lot more capable. And how do I switch between PAL and NTSC? I think I hold down the reset button maybe, and then that blinks. Let go of the reset button, and I think it's gonna be in PAL mode now. Yep, there it is. So basically the way this works, I'll link the video down below if you're interested, is I'm using a clock synthesizer to generate the master clock because it's different between PAL and NTSC. So an Arduino is powering the synthesizer, which generates the master clock, and then it also drives some address lines on an EPROM that's in the ROM socket because there's a different kernel for NTSC and PAL. So just holding down a reset button, you wait till this blinks, 1 blink for NTSC, 2 blinks for PAL. And when you let go, it resets the computer and switches modes. And there we go. Now we're in NTSC. Okay, let's turn on the floppy drive here. I don't know the order of operations. I'll turn off the computer. We'll turn on the drive. I'll turn on the floppy drive. Okay. It is just spinning. Let's turn on the computer. Okay, it stopped spinning. So let's try a directory. I don't know, it's probably a command for it. Directory, device not present. Let's reset the computer. So resetting the computer makes the drive spin. What drive letter does this show up as? Let's ask Gemini. I don't know. I was doing that in the last video. Whoa, there's a bunch of stuff there. Understanding the disk drive is a bit different. By default, it would be 8 or 9. So could it be that this is set to device number 9? Nope. Make sure the chips are in the sockets. That one was not fully in there. I mean, I'm assuming if the ROM wasn't working, if I turned this on, it would just spin forever. Yeah, I mean, it does stop. So that implies it's trying to work. Okay, so here's what I don't know with this is the cartridge thing. Does this do anything when it's working? Like, does it display disk interface or disk, or you have to sys something before you use it? I guess I should look for the manual. All right, here is the user guide. Let's see here. Features, yes. It's fast. All right, so this is for the power on sequence. You can power on any device in any order you like. When everything is on, including the computer, the disk drive will go through a self-check for a second or so and be sure everything's working. After the drive is satisfied with its own health, it will flash the red light below the drive door once, and the green power on light to the left of the drive will glow continuously. At the same time, the computer will go through similar self-tests, displaying hello message. Once the red light disk drive has flashed and gone out, it is safe to begin working with the drive. Aha! Red error light on drive flashes continuously on power up before any disk drive commands. Okay, well, it's not even coming on at all. Programs won't load, the computer says device not present. It says the cartridge is not plugged in properly. And looking through the rest of this, all standard stuff for regular Commodore DOS stuff. So this is just running a normal Commodore version of DOS splat files. Okay. So it seems like our issue is that the diagnostics are not running because the power LED is not coming on. Now it's talking about DOS error codes. We're not even communicating with the drive, so there's no way we'll get DOS error codes. Bam. I think the format's the same as a 1541, so should be able to read 64 disks. I mean, obviously, you can't load 64 programs, but we should be able to read the disks at least. Anyhow, that is it for the user manual. There was very much nothing helpful in there. So I think this is going to be a more in-depth repair because obviously this drive is not actually working and the computer can't communicate to it. It makes me think that this is more of a passive type device. I'm not sure if there's a ROM inside of here. It certainly doesn't indicate that there's any kind of ROM inside of here. And it probably just maps certain addresses in the disk drive into the memory space of the computer, and the kernel looks for activity or, I don't know, the right stuff in those addresses, and then it knows that this disk drive exists, and then it communicates with it versus over the IEC port. But without this working, it's definitely not going to communicate to the computer over this interface. Let's pop out this ROM chip. I just want to see what happens when I power this thing on without the ROM. My assuming is the disk drive will just run indefinitely. And yeah, the spindle is just spinning, which is exactly what I would think would happen when you don't have a ROM chip in there, because now the CPU is not executing any code. So yeah. So it is sort of odd, just popping that back in. Let's see what happens here. It turns off. But I'm wondering, we don't have a flash code. Is there, what's going on exactly? Like I said, when I turn off the disk drive, it does flash. So that doesn't do anything, but when you turn it off, see, there's a little blink there. So it implies that it's connected properly. Weird thing is, if you remove the ROM on a 1541, the LED just stays on permanently. It could imply that there's a problem with the 6525. Where do you find replacements of those? I don't know. I don't even know what this is. Okay, so I just kicked over the case parts. We know there's a fault with this floppy drive. Definitely some repair is going to need to be done. And I think that is going to have to be for a future video. Obviously, I said I have to go to my storage unit to grab parts for the case and stuff to, take from a 1541 to turn this into a working disk drive. But obviously, the broken case has nothing to do with it not working with this machine. So it doesn't seem like it's running the diagnostics, or it's not flashing the error codes, and then obviously it's not communicating with the computer. So while editing the video, I just did a quick look to see if I could find a picture of what's inside the cartridge, and I found this article by Michael Steele back from 2019 talking about some converted 1541 or 1570 disk drives that were converted into 1551s. I can't tell from reading this article if these are prototypes, maybe the Commodore made early on in the development lifecycle of the C16 and the +4, or these were user conversions that were done after the fact. But either way, it talks a little bit about the protocol that the drive uses and something called TCBM, which is not IEEE 488, which is what the PET used, and it's not the IEC serial that the Commodore 64 and the VIC-20 used. It was something else. And it uses some special I/O chips to make it possible. Now check out this one photo of the back of the 1541. There are the two holes that are unused, and there's that extra hole that is for the special cable that I said I would have to nibble or Dremel away to make this work. So it's kind of unusual because that looks very perfectly cut. So maybe this was something that Commodore did? I can't quite tell. And then the 1570 was modified in a different way, and that looks a little bit more homemade, and then a 15-pin connector was added. But inside, definitely these are running the same PCBs that we have on this disk drive. It's just these were interfaced to the computer a little bit differently. It says here the 6510T is a 2 megahertz version of the 64 CPU. If that's the only difference, then it doesn't matter. We can usually overclock the 6510, runs at 2 megahertz without issue, if that's the issue. The MOS 6525 is a TPI I/O controller. TPI, I don't know what that means. Now, what I came to this article to find really was the picture of the inside the cartridge, and there is no ROM in here. It's got a 6523T, which was mentioned in the user manual, and a 251-641-03. Well, it turns out the 251-641-03 is a PLA chip. From 1984, so that could easily be bad, and that could be causing our issues. And the 6523T TPI I/O controller is a chip that was only ever used in this paddle or cartridge, and it's a DIP28 version of the DIP40 6525 TPI used in the drive, i.e. the same die but in a smaller package. The TPI has 3x8 GPIO lines, so A, B, and C ports, but the 6523 only has the A port and then one line from B and one line from C. In case the 6523 ever breaks, a full 6525 can be used in its place. Whoa, well that's not good. 6525A. And this is a bit of an odd cartridge really, because the 6525 is from 1983, but look at the PLA, it has a 1990 date code. But anyways, back to the PLA. So it maps that TIA chip, so which is basically the 6523 or the 6525, to these two addresses in the computer's address space. In case the PLA breaks, it can be replaced by the PLA Advanced or The Super PLA version 4. Oh, okay, well, you know what? I'm pretty sure I have the PLA Advanced, which has dip switches on it to change its mode. Now, I don't know if there are schematics for this cartridge, but what we should be able to do is theoretically try to access those memory locations that are outlined in the article, and we should see chip select happening for this 6523. That will validate that this chip is actually working properly. What wasn't clear to me on the user manual for the drive was it kind of mentioned that the diagnostic routine only runs once the computer is turned on and the disk drive is turned on, not just the disk drive. And it has me wondering if the kernel on the computer actually initiates the diagnostic on the drive, which of course requires the PLA to be working along with the 6523 and the corresponding parts in the disk drive. Ah, look at this. This article is awesome. It says that the original schematics do exist, but there are some newer reverse engineered schematics. There it is. Very nice. Okay, so here's what I was talking about. So there is an output pin 18 from the PLA. That is the chip select line for this 6523. We need to see this line toggling anytime we try to access those memory addresses that would enable this chip. There's no way that this thing can work without this line actually going low whenever we try to access those memory addresses. As far as the reset line from the computer, it does make its way directly to the disk drive, which is probably why it resets itself when we reset the computer or turn the computer off and on. I'm definitely curious if people who are familiar with this disk drive know if this PLA is unreliable and this frequently fails. The fact that there's a replica for it probably leads me to believe that they do fail a lot, probably more often than these IO chips, hopefully, because these are generally pretty reliable on actual Commodore 64s. They do die, but generally they die from static electricity going to the joystick port, stuff like that. Well, although I've had them die just sitting there on a computer that's packed away, so they die. But the PLAs, on the other hand, we know how bad those are, especially in that 1984 date range, 83, 84, insanely unreliable. So I wouldn't be surprised if this PLA is our problem. So anyways, conclusion of this article, yeah, these 1541s were definitely created by combining a 1551 with dead mechanisms with a 1541 that maybe had dead boards. So kind of like what we want to do here. I'll take a look at the comment here. Are we even sure the 1541 is really modified? Or was really just a 1551 where the case got broken and got replaced? Kind of like what we have to do right here. And it looks like there's an actual article about how to convert a 1541 board into a 1551. This looks like some serious hardware hacking. Let's just translate this into English from Hungarian. Zoom in a little bit. So the 1541 has two VIAs with a total of 4 byte ports. That's ports A, B, C, D. And the 1551 has a TPI with 3 ports and a special 6510 with 1 byte port. And this poster goes on to talk about how these different ports are used. So PA is used for the TCBM on the 1551, status, data, IEC stuff. We got read-write head stuff. And then there is the activity LED. Oh, well, that tells us a lot right now. I wasn't looking for this info, but the activity LED on the 1551 comes from the CPU itself, along with the motor signals and the drive steppers and some other stuff. So that's interesting. That tells us that it's not flashing by design. And maybe it's what I said about the user manual, where it needs to have a command from the connected computer to initiate the diagnostics. So this user here says, if I were to run the CPU at 2 megahertz instead of 1, and map the necessary VIA registers to the appropriate address registers, hide the differences in the registers, then it should work. Skimming the article talks about using a CPLD, and yeah, interesting. Oh yeah, there's the CPLD. So I think the original solution of those chips didn't work, or maybe it did. Or, is that on the bottom side? Oh, it's on the bottom side. I see, it's underneath there. It looks like with this contraption hooked up to the original paddle, there it is, an actual directory listing from Commodore 1541, totally modified. My father, it works. You mean it freaking works? I can hardly believe it. There is the solution all repackaged back into the 1541-2 disk drive. This sits under the mechanism. What a freaking epic mod. There's the connection that goes to the paddle. This is absolutely amazing. This was all done back in 2012. Wow. Real props to this user for doing this. And look, it even had an update last year, some small typos and stuff. Well, that was really cool and a bit of a tangent I didn't expect to go on. Thank you, Michael, for posting this article, and thank you to the commenter who referred to that Hungarian article. Awesome, really cool. And I guess I have ideas of where to go with the diagnostic process for this drive. And I'm definitely going to have to open the cartridge up and we're going to have to check that chip select thing. That's absolutely the first thing that needs to happen. And I'm very curious to know if you have one of these disk drives or you're familiar with how they work, does the diagnostic routine where the LED comes on the front of the drive really only work when the Commodore 16 or +4 is turned on when everything's connected? That's the key piece of information which I definitely need to know so I don't go on a wild goose chase, potentially going after the wrong thing. But yeah, PLA, I think it's this PLA. So that is going to be it for this video. Thank you very much, Michelle, for sending this thing in. Once this is working, I'll be curious to see how fast this is compared to the normal 1541, which we can also plug into the back of this thing, IEC port, and load the same disk, which I'll need to make, and we'll see speed difference. But I'm assuming there's going to be a significant speed difference because of the parallel interface. But knowing Commodore, they probably screwed something up and it's not that fast. Who knows? Anyhow, thanks again, Michelle, for sending this in, and look for a future video where I try to repair this, and I'll be checking the comments to see about the compatibility of that chip and also the CPU. While you're at it, if you know about the CPU, could I use a Commodore 64 CPU in here or not? What's the T version? What's the difference? That's kind of curious as well. So there we go. If you liked this video, thumbs up. If you didn't, you know what to do. A huge thanks to my supporters. Their names are scrolling beside the screen. They make it possible I do this full time. Without them, I would have to get a regular job and I wouldn't be able to make nearly as many videos. So thank you very much. You can become a supporter. There are links down below. I'll try to link those other videos I mentioned in this one down below as well. So check those out and I guess watch for a future video. So that's going to be that. Stay healthy, stay safe. I'll see you next time. Bye.